last video we talked about this idea of differentials. So let's finish up talking about definition of differentials. There's many different parts. So if we look at this first part here, dy equals f prime of x dx. That simply comes from the definition of a derivative, which is dy dx equals f prime of x. And then all we're doing is multiplying both sides by dy dx to get the dx to the other side. So that's all that's going on there. Okay. And then remember right here that dy is an approximation of delta y. And all that means, if we look back at our picture here, the change in the y value for the secant line, that's this here, okay? That's this amount here. That is not going to be the same as the change of dy, the vertical change in the tangent line. It will only be the same when the secant line becomes the tangent line. But it'll be an approximation. So, another way to think of this is dy is approximately f prime of x delta x. Okay? Since dy dx, that's the definition of derivative, is approximately delta y delta x. Again, this is the slope of the tangent line, this is the slope of, this is the slope of the tangent line, this is the slope of the secant line. Okay? But dx is always going to be equal to delta x. The change in the x values over here, those aren't going to change. So that is why you can conclude that dy is approximately delta y. Okay? And then this last part here, remember that delta y over delta x, the secant line, this is the definition of the secant line. It's just the slope of the secant line, where delta y is f of x plus delta x minus f of x. Let's take our example 2 here. We want to compare delta y and dy. So we know delta y over delta x, that's the slope of the secant line. Okay? Where dy has to do with the slope of the tangent line. Okay, so the part that they care about, notice here, if I multiply all the way through by delta x, I'm just going to be left with delta y equals f of x plus delta x minus f of x. Here, if I multiply 2 by dx, I'll be left with dy equals f prime of x dx. They want us to compare these two. So first of all, they tell us let y, and I'll call that f of x, equal x squared. They want us to find dy. Okay, so we're going to use this guy to find dy. So dy would be equal to f prime of x, which is equal to 2x, and the x value that we're looking at is when x is 1, so this would be 2, and then dx is equal to 0.01. So this is going to be 2 times 0.01, which would be equal to 0.02. They want us to compare this to the value of dy when x is 1 and delta x is 0.01. So now f of x plus delta x would be equal to x plus delta x squared, where for this particular problem x is 1, delta x is 0.01, so this would be 1.01 squared, which 1.01 squared would be 1.0201. So now we know delta y is equal to 1.0201 minus f of x. Well, f of x is equal to x squared. When x is 1, this would be 1. So this is going to be equal to 0.0201. So now we can compare these two. It's a pretty good approximation. They're pretty close to being the same value.